Good afternoon, class. We're going to continue our work with the movie site, and what we're going to do today is we're actually going to deploy this to a production environment. So this makes it accessible on the web, so that we could visit this particular website from any internet-connected computer, and this is kind of a good practice for publishing any application that we want to publish to the web. Now, there are a lot of different ways that we can publish things to the web. We've talked a bit about virtual machines, and we've talked about cloud services. We're going to be using Azure, which is Microsoft's cloud services provider, and we're going to use some of the built-in functionality that's been added to Visual Studio, which really makes this quite easy and straightforward. If we were to deploy on our own, say, Linux box, we would have to copy over our actual binary files into that server and go ahead and execute it there. The solution we're going to be using actually does most of that for us, and that's all leveraged through Visual Studio. So if you come into Visual Studio, right-click on your project, notice that there is a Publish option in this drop-down menu. And if we go ahead and click on that, it's going to ask us where we want to publish, and actually there's a lot of different built-in options that we can do with Visual Studio. We're going to be using Azure, but we could also publish to any Docker container registry. So Docker is one of the most popular of the containerized approaches to deployment. And a registry is basically a library of Docker instances which provide those programs. So a lot of open source projects end up being published as Docker containers now. We could also publish either to a local folder on this computer, or we could publish to a remote folder through FTP or secure FTP. So we could actually deploy this on a remote server that we've already set up, so a Linux box that we have access to, or an IIS server. If we have a Windows server that's running IIS, we could deploy it directly to that service. So these are kind of the more traditional web app ways of deploying, and Azure and Docker are really kind of some of the new kids on town, which are cloud-based services. And we're going to go ahead and pick the Azure option here. And notice that it gives us several options inside of here as well. We could do a traditional virtual machine, which means we have complete control over the infrastructure. We're basically working on a virtual PC hardware, and we could install Linux or we could install Windows on that on that hardware, and then install .NET, and then we can deploy our application onto that. We can also do an Azure container or an app service container. So this is the registry version of that, where we're just putting it into a public library that we could then pull it back out of at different points, or an Azure app service container, so we can containerize it and run it on the Azure app service, or we can publish it to either Windows or Linux in Azure app service. So these are actually also kind of a containerized sort of approach. We're going to pick the Linux app service right now. So you should already have your subscription as a K-State student set up, so this subscription option should be Azure for students. If you haven't done that step, go back and do that, then you can come back in here and go ahead and continue from this point. And then we have to have a resource group that we want to put that into, and we don't have one right now, so I'm going to actually create an Azure app service to hold this, and we could call this whatever we want. I'm going to call this CIS 400 demo. And then again, this is my Azure for students. The resource group, we get to specify where we actually want this hosted, and then a hosting plan, which this is giving us kind of the default that they want students to use when you're setting this up with your student service. But the plan would basically allow you to pick how many servers you want this running on, so basically how much scalability you want and how much computing power you need behind it. So I really don't have a lot of choices as a student. They're pretty much funneling us into what they want us to use. But if you actually were paying for the service, then you'd have a lot more options there. And of course, they all have different costs associated with them. So then we can go ahead and say create that service, and this will take a little bit to run. Now you can see that it has gone ahead and just created our demo inside this Network Watcher resource group. So we're pretty much ready here to finish our steps. And that will take us back to Visual Studio. Now you notice that we have a publish page, which is part of our movies as well. So if we click on the movies, we have our usual overview, our connected services, but then we also now have this publish, which is set up to deploy to CS400 demo, web deploy. And notice that it gives us a URL, the resource group configuration that we're doing a release configuration. We're targeting NetCore app 2.1 and all of those details. And we don't have configure as delivery set up or any service dependencies. We don't need those for this particular one. So if we're happy with this and we want to go ahead and publish our website, we just click this publish button. That's going to go ahead and start a build. As you can see, we're going to build all of the DLLs, and then once we finish building those, we are going to go ahead and deploy those by pushing those out to that Azure web service that we've set up. And notice that once it finishes publish step, it will wait for that to basically be ready. It's going to start the web app. Once that web app is running, it will tell us it successfully started that and our publish has succeeded, and it will take just a few moments for this to finish up, and then it's going to give us a URL, which is this URL right here, which is a public facing domain that we can visit to actually see our website. And there we have our website. It has loaded up. You can see we're getting our values. We have the search form. So if we go ahead and search, notice that our search functionality is working, and so is our filtering functionality. So all those pieces are working. However, you might notice that this search form does not look like the way that we have seen it when we run in debug mode. So let's go ahead and run this in debug. And notice that here we have the search form has that nice gray border. We have them side by side, and of course yours might look a little different than this, but definitely it looks different than this. Now if we go ahead and inspect and look at our network call here and just reload this, notice it is loading site.min.css. If we go look at that, that is a minified file. And we can see all of this information in there. So this is our CSS in a minified form. If we do the same thing on our debug copy, we also have, in this case, site.css, which is our raw CSS file. And notice that it has all of this information, and none of that actually matches up with this information. And that's because this min file is actually created from the original template, and we're not replacing it with our new CSS that we've added here. And if you look, there is a link up here in the top. It suggests going and looking at client-side bundling and minification for details on how to bundle and minify. And what we're really talking about there is we can have multiple CSS files in this CSS directory, and we can combine all of those into a single CSS file, and in doing so we can remove white space and a lot of the consumption of memory that's being caused by that. So this is the link. If we will follow that link through for ASP.NET Core 2.1, which is what this project was written in, which is actually pretty old, but now we're actually up to .NET Core 5.0. So depending on which version you're looking at or your application is, these instructions may change a little bit. But basically, we combine all of our CSS files into a single file with bundling, and then with minification, we take out all the comments and all the unnecessary white space. So this is the minified version of this. So you notice it gets a lot smaller. So that happens with JavaScript, and that can happen with CSS. And the real point is, by minifying, you actually reduce the amount of data that you have to send in terms of, for example, in this case, kilobytes transferred, by a significant amount. And of course that varies depending on our CSS. The problem is that this is not done automatically for us. We actually have to enable it, so that we have to add this build bundler minifier NuGet package to our project in order for that to work, and then we have to configure it to take and spit out the site.min.css based on our input file of www root CSS site.css. We could also not minify. If we go back into our pages and go look at our layout, notice that we have environment include development. So in development mode, we're including the full raw file, but in other environments, so the exclude development, we're including the minified version. So if we were to do that with our CSS, that would fix it if we just took out this environment include and deleted this one so that we're always using the raw form. But if we want to do the minified version, we need to go ahead and follow these steps. So the first thing we need to do is go ahead and in our tools, we're going to go down to NuGet Package Manager, and we're going to go ahead and manage NuGet packages for the solution. So that loads up our package manager here, and we want to search for that one that they specified, which was Build Bundler Minifier. And there you can see we have Build Bundler Minifier. We're going to add that to our project. Click the Install button. This goes out and grabs that package and installs it. We tell it OK. And it's telling us that once it's installed this, we don't have the bundleconfig.json file, which is the next step, this JSON file they're talking about here. So we're going to go ahead and add that to the root of our project. So we will add a new item, and we're going to find JSON in this list, JSON configuration file. And this one is specifically named bundleconfig.json. And we will change this content to match what we see as being the requirement here, which is basically the input and the output for our CSS. So this needs to match what our output was supposed to be, and this needs to match what our input is. So site.css. And if we were going to do JavaScript minification as well, we'd want to do a comma and then go ahead and have our JavaScript minification syntax in there to basically follow the same idea, where we have an array of all the input files. So if we had additional CSS files we wanted to bundle up, we would just list them as a comma separated list. So maybe www.root CSS other.css, but we don't actually have any other files, just this one. And we're not using JavaScript in this particular application, so we don't need to bundle and worry about it either. So if we do this step and then save that, and let's go ahead to see if it builds for us. You can see it processes bundler config, so it does that bundling for us. And of course, this is still going to work just fine because, again, in debug mode, we're looking at this site.css, not the packaged one. But if we now go and deploy or publish again, our new published version should include the bundled files. And you can see there that it ran the bundler config, ran and everything. Looks like it's all succeeded. We got 0 failures. It's restarting the web app. And now you can see we have our CSS in place. And our search still works. No PG rated movies with love. And we have all of our everything's working, and notice that we now have a real domain, and we are also serving it using HTTPS, so this is a securely served web application. If that certificate is provided for us by Azure, as long as we're using this particular provided host name. If we want to create our own domain name, we would have to register and purchase that domain name, and then we would point that domain name's server entries at this IP address, and then once we have it pointed at our IP address, we would also want to generate a security certificate to go with that and add that security certificate as well, because the security certificate is based on the domain name, not on the IP address, on the domain name. So we do need to have a security certificate for this as well if we're deploying it on our own. And if you're going to do that, I would highly recommend going and getting that from Let's Encrypt, at least as a student, because these are completely free. They don't carry the insurance that you would get if you bought it through one of the commercial vendors, for-profit vendors, but it does give you everything you need to encrypt, and honestly, there's not any real reason for most of your applications you would need any insurance or other protection. This will get you up on the web with a secure website, which is a really nice thing to have available to you. Okay, that is all there is to actually deploying through Visual Studio to an Azure Web Service cloud provider. So this is a very easy way to get your web applications, at least the ones you're building with .NET, deployed. And if you wanted to deploy some other kinds of applications, you would probably do that through a virtual machine, which could also be hosted on Azure, but then you'd have to log in as the root user and install all the software that you needed to support that. So if you're, for example, doing a JavaScript-based backend, you would need to install Node and any additional libraries that go with that. If you're doing a traditional Apache server, you'd have to install Apache and be running that. But this is the basic idea behind how we would get those up and running. So that wraps us up for this exercise. Go ahead and turn in the link to the URL that you have created for that project, and that's what we'll be looking for.